Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into the wild world of setting up a Banana Pi M7 as a KVM hypervisor with ZFS on Debian. Buckle up, it's going to be a bumpy ride.
A Banana Pi M7? Sounds fruity. But seriously, what's the appeal of using such a board for a hypervisor? I mean, isn't that usually a pretty beefy server task?
That's the beauty of it. This little guy packs a punch. 8 cores, 4 A76s and 4 A55s. Plenty of RAM options. And even PCIe 3.0 for an NVMe drive. Perfect for a small-scale private cloud, or QEMU, as they say. Imagine a homegrown cloud, all from a single board.
Okay, I'm intrigued, but the article mentions some compatibility headaches, specifically with the kernel and NVMe drives. Sounds like a recipe for frustration.
Oh, absolutely. The RK3588 is relatively new, so kernel support isn't perfectly smooth sailing. They had to use Debian, a custom Debian build, to get things working. And the NVMe compatibility? Let's just say it's a bit of a lottery. Some drives work flawlessly, others, not so much. Power supply is crucial too. You need more than your average 5v3a.
So which kernel version did they settle on? And why Debian Bookworm?
They went with Debian Bookworm because of the ZFS version. Ubuntu's OpenZFS 2.2.2 doesn't play nice with newer kernels. But Debian Bookworm's 2.2.7 supports up to 6.12. They used the current Rockchip RK3588 kernel, version 6.12.0, which worked like a charm. It boots!
Ah, the joys of kernel versioning. So they built a custom Debian image. Did they do this on the Banana Pi itself?
Nope, that would be unwise. They used a regular x86-64 machine, leveraging QEMU emulation to build the image in a Docker container. Clever, right? Avoiding the need to install all the build dependencies on the host machine.
And once the image was built, they flashed it onto a micro SD card, right? And then what about storage for the VMs?
Precisely. Micro SD for the OS, and then they use that NVMe drive for a ZFS Z-pool. ZFS for the win. Checksums for data integrity, snapshots for easy rollbacks, and it integrates nicely with libvirt. Fantastic.
But ZFS isn't without its downsides, is it? Performance overhead, for one.
You're absolutely right. There's a performance trade-off. But for the added data integrity and features, they felt it was worth it. Plus, they used encryption with the Z-pool, leveraging the existing LUKS encryption on the root file system for the key. A bit risky, but convenient.
Risky indeed. Storing the encryption key directly on the root file system? That seems like a single point of failure. What about libvirt setup? Was that straightforward?
Relatively. They installed the necessary libvirt packages, including the ZFS storage driver. Then, just to test, they spun up a Debian VM using /virt install. It worked! A testament to their hard work.
So in the end, a successful, albeit slightly adventurous, journey into the world of embedded hypervisors. Thanks for walking us through this. It's certainly given me a new appreciation for the power of these small SBCs.
My pleasure. And remember, folks, always back up your data. And if you're attempting this at home, be prepared for some troubleshooting. But the reward of a self-hosted cloud on a Banana Pi? Priceless. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.